Hello again, chemistry students. All right, we're gonna have some fun today. Last week we learned about chemical reactions and how to balance chemical equations. And so this week we're gonna dig in a little bit more about different sorts of chemical reactions. So we're gonna talk about decomposition reactions, we're gonna talk about combination reactions, single replacement reactions, double replacement reactions, combustion reactions. But I thought right here we'd try a decomposition reaction. Maybe some of you have watched videos of elephant toothpaste online, and I have too, but I've never tried it. So let's give it a go. All right, so I was told we want to take some hydrogen peroxide, about a half a cup, and that's about 125 milliliters. So I'm gonna look at, that's about right here, my beaker. So we're gonna put some of this in here. And it's not very exact because really, in fact, I might just use all this up because I don't have very much hydrogen peroxide. So we're just gonna go for it, all right? So hydrogen peroxide is H2O2. So we've got two hydrogens and two oxygens. And what we're gonna do is a decomposition reaction. We're basically just trying to decompose this into hydrogen and oxygen. And so in order to see the oxygen, it's gonna become, oh, not hydrogen, but water and oxygen. And so in order to see the oxygen, we want to make it bubble. And so actually, I think I want to add some dish soap. And you know what? I left my dish soap over there. So my lovely assistant is going to hand me some dish soap. So I'm going to just add a squirt of dish soap. All right, and I'm going to swirl that around. And what that will do is mean when the oxygen comes out of solution, I can have bubbles. And if I want to see that even extra, I think I'll add some food coloring. Let's make it red just for fun. All right. Okay, so I'm going to swirl that around as well. So what I really care about here is the hydrogen peroxide. The rest of it is just for the fun of it. What do you think? All right, so hydrogen peroxide, a little bit of soap. Now, how do I make it break down? Well, if I let it just sit here, it might do it on its own, but I'm not going to see much. It's not going to be very exciting. So what I want to do is add a catalyst. We're going to learn more about catalysts in future lessons, but they're things that just speed it up. So what I have here is some quick rise yeast, and I'm just going to add about a tablespoon of yeast to some warm water. Now, yeast is actually a living organism. And so the warm water and the yeast, I'm going to swirl that together a little bit. And what that will do is it will actually get the yeast to start to grow. And the yeast will act as a catalyst to start the breakdown of this reaction here and start it breaking down into water and oxygen. And it should be a rather quick reaction. So let's see how exciting this is. Well, not as exciting as on TV, but you can see it going rather rapidly. And I think what the rise is all of those bubbles of oxygen are expanding, because when it becomes oxygen, it's a gas and it's much less condensed than it is when it is liquid. Pretty cool. Definitely didn't add enough food coloring to make it as exciting as it might have been. So the oxygen is expanding, making sort of a foam with the soap. And when this is all done, there will be water left in the bottom of the beaker. Okay, it's a little bit later and this reaction is still going. It's just not super fast. You can see when I scrape off the top. So either I have less potent hydrogen peroxide. The kind in these bottles is usually only 3% hydrogen peroxide, so a lot of it is water anyway. Or it could be just my proportions when I mixed it together weren't right to make this a really fast reaction. But it's interesting to see that it's still going on several minutes later. Also, I can tell from this foam that it's warm. So there is a slight exothermic property to this reaction, which is kind of fun to see. Okay, I wanted to come back and show you the end of this experiment. This has been sitting for quite a while now, and you can tell that the foaming has pretty much stopped. And I wanted you to see what's left in the bottom. Do you see this? There is not much liquid there. It's a little bit faintly red from the food coloring that we put in, and maybe a little bit from the yeast as well. But can you tell how much there is? If you'll recall, it's hard for you to see with that foam, but we put in about 150 milliliters, of liquid. So it was about up to here. And in this beaker, I had 50 milliliters of water. So I added 50 milliliters of water to 150 milliliters. So there should be like 200 milliliters of liquid in this beaker if we hadn't had a chemical reaction. But instead, we decomposed a whole lot of that liquid into oxygen, which went into foam everywhere. And you can tell that we have so little, I can't actually even tell you how much liquid there is left. It's not much. It doesn't register on the lines on this beaker. So we have a little bit of liquid left, mostly water with some food coloring and some other stuff in there. And most of the oxygen made bubbles and escaped into the air. So I think that's really interesting. I did check on my hydrogen peroxide, and it does say here on the back, it says 3% solution of hydrogen peroxide. So we started out with a lot of water in the first place too. So I think we lost some of the water in it just foaming up and over. But let's look at this decomposition reaction and balance the equation and see what happens, okay? So if we write this down, we have H2O2, which is hydrogen peroxide, and that is going to yield H2O plus O2. So let's balance the equation. We have, in the H2O, we have 2H, and we have 1 oxygen there, plus we have 2 oxygen. So we have a total of 3 oxygen. And on this side, we have 2 hydrogen and 2 oxygen. So we need to get more oxygen over here. So we already have 1 of those molecules. So we can say 2 molecules of hydrogen peroxide. So to add 1 more molecule of hydrogen peroxide, we now have 2H2. That's going to make this over here. We're going to have to add more hydrogen. So that's going to say 2H2O. So we now have 4 hydrogen. Over here we have 4 hydrogen. We have 4 oxygen. So that's 2O and 2 oxygen. We now have 4 oxygen on this side. We have a balanced equation. So this is our final balanced equation. So you notice that from 2 hydrogen peroxide, we get 2 molecules of water and 1 molecule of oxygen. But as I said before, the oxygen is much bigger than the original liquid was because it expands a lot. So we saw lots of expansion there. But it's interesting to me that we have so much less liquid. I don't think it's because the water is so much less than that original hydrogen peroxide, because we still have 2 molecules of water for every 2 molecules we had of hydrogen peroxide. I'm guessing that we lost a lot of water in the foaming as well. Have fun with this week's lesson. I hope you learn a lot more about chemical reactions.